Fungi are all around us. They're under our feet in the soil, but you can find them in various substrates. We can find them in the wing tanks of jet aircraft, on the talons of an eagle, even the eye of a crocodile at London Zoo, where one of our green muscadine Metarhizium anisopode fungi come from. You are never far away from a fungus. The collection here contains 30,000 living microbes. Around 27,500 of them are fungi. We've got about 2,500 plant bacteria. Historically, they were stored under oil, such as this culture here, which is basically a living fungus growing on some agar and overlaid with oil. You can see there the lovely colour it's producing. That's because it's producing a pigment that's dissolved in the oil, an organism called Phyllothera chrysogenum. But now we store them by more advanced methods such as cryopreservation and freeze drying. It's important to keep fungi for a whole host of reasons. If you're a plant pathologist, it's really useful to come back to us to use the resources we have to compare current strains with ones that were isolated previously. We can use techniques such as next generation sequencing to actually look at how an organism has changed over time. And you can learn a lot from what those genetics tell you. We often say fungi are the Jekyll and Hyde, so they're the good and they're the bad. In this collection, unfortunately, we don't have anything that is pathogenic or harmful to humans. We leave that to our friends at Public Health England, but we do have strains that will be more dangerous if you were an insect or a plant. To give you some examples of organisms we have in the collection, Fusarium oxysporum is the causative agent of Panama disease of bananas, and there's a lot of work and attention to that in the world at the moment. Another one we have is known to most people as dry rot. It occurs in buildings, but actually it's a very interesting and unique fungus. We have others such as Penicillin camembertii, and as the name suggests, camembertii, cheese, so it's used to help produce cheese. So we have a whole range of really useful microorganisms in the collection. The biggest challenge is that in the media, fungi are often portrayed as being the bad guys, but there are so many things that fungi can deliver. They can be used as food, they can be produced for food. Fungi that produces enzymes, metabolites, they can biodegrade waste products. And increasingly now that we're using them as bioinoculants in the field to actually help support plant growth. They are so useful. What we have here is an ampoule of Sir Alexander Fleming original penicillin producing strain of Penicillium. This particular strain was actually produced in the Second World War in America. It came to us in about 1947 from the then National Collection of Type Cultures. This ampoule is unique because it is one of the last surviving ampoules from the wartime period. So this is a culture plate of the original strain of Penicillium. So when the fungus is growing on agar or in the broth, it will produce penicillin, which is the active compound that is obviously used as a drug. And of course, one of the major problems at the moment is that bacteria are becoming resistant to many of the original drugs that were produced as antibiotics. So the challenge for science now is to actually find new drugs that will combat this increasing resistance, which is a problem throughout the world. So many products have come from fungi over the years that have been developed, and we know that in our collection there are potential other new bioinoculants, there's potentially other new drugs, new pigments, and that is why we maintain the collection.